Okay, so on Friday, we took part of our notes for, I think this is notes number 7. I'm still in note 7. I'm on, here's our graphs we did with intercept form. I'm just on the next page, and we're just going to finish up the thoughts here that are on the last page. So first thing I want you to do is I want you to go through, and I don't want you to look at this side at all, okay? I want you to just go ahead and factor this first quadratic and factor the second quadratic. So pause the video and take a moment and factor each of those. Okay, so here I have my first quadratic set equal to 0 already. I went ahead and factored, and I get my two answers of -4 and 2. There's the solutions. Now I told you to factor both of them, and hopefully some of you realized you can't factor this one. Look, I went to go factor it. Factor or use the quadratic formula. So we should have looked at our discriminant here, realized that's not a perfect square, and switch to using the quadratic formula. So x equals -b plus or minus the square root of, we know our discriminant is going to be 57 all over 2a, which would give me 4. Now for this, because I know where we're headed here, I want to get the decimal answers for this problem, just so I have a good estimate of what those values are. So instead of just leaving it here, I'm going to go ahead and go 3 plus the square root of 57, entered, divide by 4. So one solution then would be 2.6 rounded. And my other solution, if I do 3 minus the square root of 57 over 4, gives me another solution of -1.1. So there's my kind of best estimate of my solutions for this quadratic that we had to use the quadratic formula on to solve. Okay, so now let's go back and graph each of these. So on our first one, to graph, it's in standard form. So I'm going to start with -b over 2a, which gives me -2 over 2 times 1, or 2, gives me an x value of -1. So remember, it's in standard form. So I'm saying my vertex is at -1, comma, we'll find the other value. We know our y-intercept is at 0, -8. We know that it opens up and that it follows 149. I have an a value of 1 here, so I'm just straight 149. Okay, don't know what that little dot is, ignore it. So here's my descriptions, right, of what's happening here. We still got to figure out what y is. So I'm going to go ahead and plug -1 in for x, which gives me 1, -2, -8, or -9 altogether. Okay, so my vertex point, let me get rid of this. My 8-year-old had doodled on this paper a little bit, so probably from that. That's why I have white out here as well. Okay, there we go. So we're at -1, -9, a little bit off our paper, but not too bad. Okay, there's my vertex. I could draw on my axis of symmetry if I wanted to. Okay, we know it opens up. We're going to follow our 149 pattern, which is going to have us hit our y-intercept anyway. So if I go 1, 1, 1, 1, go over 2, up 1, 2, 3, 4. The same on the other side, over 2, up 4. And that's probably enough to graph, but I'm going to keep going because I kind of know, I know where we're headed here. So I'm going to even go over 3, and I want you to do the same and go up 9. And go over 3 and go up 9. Okay, there's a really good graph of the parabola y equals x squared plus 2x minus 8. Okay, and then it says, where do you see the solutions from part A show up on the graph in part B? So our solutions are 2, -4. And hopefully where you see them is right here. And we've talked about that quite a bit, right? That our solutions, when we're solving a quadratic, are the x-intercepts of my graph. So if in factored form, I get 2 and -4, that's where it should be crossing my graph, at +2 and at -4, and it is. Okay, and notice again, just like when we were graphing an intercept form, that my vertex point is directly in the middle of that. Okay, between 2 and -4 would be -1. That would be the average of those two x values. So where we see our solutions from part A show up in part B would be that it's our x-intercepts. Okay, let's look at the one that we had to solve using the quadratic formula. Again, graphing in standard form. So -b over 2a, giving me 3 over 2 times 2 or 4. Okay, so the x value of my vertex is 3/4. And the y value, plugging 3/4 in, gives me 3/4 squared, giving me 9/16. This is going to be 9/4. So then I have 18/16 minus 9/4 minus 6. I'm going to take that even a step further and simplify 18/16, both divisible by 2, giving me 9/8. Now I'm going to get my common denominator. So this would become 18/8. And this would become 48/8. And now I have a common denominator, so I'm just going to add them up, giving me -57/8 for the y value of my vertex. So here's our descriptions, right? So vertex is at 3/4 and -57/8, which -57/8 we could also think about as -7 and 1/8. Okay. Our y-intercept is at 0, -6. It opens up because A is positive, and 1, 4, 9 would now follow 2, 8, 18, okay, because our A value is 2. So graphing this as best we can, 3/4 and -7 and an 1/8. Maybe I'm there. Not perfect, but pretty good. My y-intercept is 0, -6. Okay, so I'm just going to place that point on there. And then I'm going to go over 1, up 1, 2, and over 1 the other way, up 1, 2. I'm going to go over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And same on the other side. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8. Okay, as best I can, and I know we're making an estimate because we have a fraction for our vertex there. And then go ahead and draw that parabola in. There's a sketch of our parabola. Now let's look at where our solutions are. 2.6, that looks pretty good, doesn't it? Okay, 2.6 right here, there's one solution. And -1.1, pretty good as well. Okay, looks like it's actually on -1, but we know our solution is actually -1.1. So again, the solutions for the first part, even when it's not factorable, but we use the quadratic formula, show up as the x-intercepts on our graph in part B. So to summarize the solutions to a quadratic equation are the x-intercepts on the graph, which we've already talked about. We've talked about quite a bit. Now I want to take that just a little bit further and talk about different types or numbers of solutions that we could have. So flip this over. I want you to cross this off because we're not going to be solving an equation graphically, but equations graphically that has no solution. So mentioned before when we were working in Zoom classes, there's going to be times that our graph doesn't cross the x-axis, okay? So I'm going to skip this first part and go right to here. Here I have a quadratic in standard form, okay? So I can go ahead and write my descriptions down. I know that my y-intercept is at 0, 5. I know that it opens up and that it'll follow the 1, 4, 9 pattern. And my vertex negative b over 2a. For this, b is 0. So it's just going to give me 0. 0 divided by anything is 0. And if I plug 0 in, it gives me a y value of 5. Okay, y equals 0 squared plus 5. So you'll notice that the y-intercept and the vertex are the same point. Now the scale on this graph is kind of wonky. You see how it's going by 2s? So 0, 5, we're just going to estimate it's right there. And then we know it opens up following 1, 4, 9 pattern. So over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, estimate maybe here, over 2, up 4. It's the sketch of our graph. Now, if the solutions for our quadratic are x-intercepts, notice it never crosses the x-axis, okay? Or there are no x-intercepts. It never crosses the x-axis. It's never going to cross the x-axis because it's going up. It's never going to go below where our vertex is, which is floating above this axis anyway, okay? Now, if we were to solve this algebraically, so going back up to the top here, we'd go, oh, we should solve that using inverse operations or square roots. So I'd subtract 5, then I'd get x squared equals negative 5. And then when I go to solve, I'd go, wait, can't take a square root of a negative number. And we'd write no real solution, cannot take the square root of a negative number, okay? So if this had been at the beginning of this unit, we wouldn't be able to solve this algebraically, or we'd write no real solution. And now we can see that this quadratic graphically never crosses the x-axis, has no x-intercept. So they have that relationship there. And so when we're graphing a quadratic, there are 3 possible outcomes. Okay, one, what we'll see a lot of the time is that the parabola will cross twice, and that I will have 2 real solutions. Okay, they might not be integers, they might be decimal values, ones that we'd have to solve using a quadratic formula, like what we saw on the page before, but it's going to cross twice, and we're going to have 2 solutions. Now, it's also possible that our graph just touches the x-axis, that our vertex point is sitting on the x-axis. And if that's the case, then we have 1 real solution. So as an example here, okay, what was our graph on the page before? So if I had x squared plus 2x minus 8, and we said that's x plus 4x minus 2, there are my 2 solutions, right? So just as an example of what 2 real solutions look like. Doesn't necessarily match my graph. An example of what 1 real solution would look like. So maybe I have y equals x squared minus 4x plus 4. If I were to factor that, that would be x minus 2x minus 2, or x minus 2 squared, where we have that same solution twice, and I get x equals 2 for my solution. Okay, so 1 real solution. If this was the situation, then it only hit the x-axis once, and then either go up or go down, depending on what my a value is, right? This solution, it's hitting the x-axis twice. And on our last solution, like what we have above, x squared plus 5 equals 0, x squared equals negative 5, and then we just write no real solution. Okay, the third possibility, okay, 2 solutions, 1 solution, no real solution. No real solution. Could have an imaginary solution, but that's algebra 2 class, okay? Let's re-sketch what we had up above. Okay, no real solution means it's never crossing this x-axis ever. Okay, and what's important is x-axis, not where it crosses the y-axis. Okay. So you may be asked those questions when you do some of your work. Is what are the x-intercepts, or what are the roots of the equation? And sometimes there are no real solutions to that quadratic, and that's what it would look like graphically when that's the case.